In this video, we're going to take a look at the empirical rule and how we can break down the normal distribution and talk about it a little bit more in detail. So the empirical rule says that 68% of our data lies within one standard deviation, 95% of our data lies within two standard deviations, and 99.7% lies within three standard deviations, which might be hard to kind of wrap your head around. So I always think with the normal distribution in particular, I'm always going to draw a picture. I think it's really helpful. So here I've got my normal distribution. I know that for my normal distribution, the mean sits right in the middle. So here we'll use mu for the mean. And first off, it says 68% is within one standard deviation. So what that means is if I take my mean and add my standard deviation, so here I would have the mean plus a standard deviation, and then subtract the standard deviation, the mean minus the standard deviation. That's moving one standard deviation here to the left and one standard deviation here to the right. And what the empirical rule says is between these two values, if I look at just between those two values, that's going to make up roughly 68% of my data. So here is 68% of my data, and the mean, of course, is right here in the middle at the highest point of my normal distribution. And then I'm just going to continue this process on. So if I wanted to move from this point right here, the mean plus my one standard deviation, if I wanted to move to the right again, well, I'm adding another standard deviation. So this point right here would be the mean plus two standard deviations. And then similarly, if I wanted to move to the left, I would want to subtract a standard deviation. So here I've got the mean minus two standard deviations. And what the empirical rule tells me is that between these two numbers, between these two, we have 95% of our data. And these two, I think, are particularly important when we look at these two because this makes up the middle 95%. Anything that's further away on either the left-hand side over here or the right-hand side over here, we tend to call these values over here in the tail unusual because they have less than a 5% chance of occurring. So anything in those highlighted regions right there, we tend to consider those to be unusual data points just because they have less than a 5% chance of occurring. Some books might define it differently, but that's what I've seen most consistently, and that's what we're going to use in our class. And then if we complete this process one more time, adding one more standard deviation over here on the right, I have the mean plus three standard deviations for this point, and then the mean minus three standard deviations over here on the left. And if I look at between those two, we have 99.7% of our data, so nearly 100% of our data. Now, this is what the empirical rule says, but it turns out we can break this down a little bit more if we use the fact that the normal curve is symmetric. It's a really handy tool to use. So if I wanted to look at, let's say I wanted to know how much of my data lives right here in this particular section. Well, I could say, well, in this section right here, in this middle two, we said 68%. But I know that this part over here is a mirror image of this part over here. So what I can do is I can say, well, if it's a mirror image, they should have the same amount. So I can take 68%, 68 divided by 2, to end up with 34%. So that means that there is 34% of my data right here and 34% of my data right here. And I can kind of continue that process as I move to the left and to the right. Now, I do have to be careful here because when I go to move into the next section, so maybe I want to say, okay, well, how much of my data lives in this portion of my normal distribution? I cannot just take the 95% and divide it by 2 because we've already talked about the 68%. I would be counting that twice. I want to know just in this section right here. So if I wanted to do that, I have to count just the section, or excuse me, just the area in this portion of my normal distribution and this portion. Well, that should be fairly easy to do. I'm just going to take 95 minus 68. So over here, I'm going to take 95% minus 68%, and I should end up with, I believe, 27%. Let me just double check to make sure I'm not making a silly mistake here. 95 minus 68 gives me, yes, 27%. So that 27% lives split evenly between this area and this area over here. So now at this point, I can take that number and just divide it by 2 to come up with 13.5%. So that means that 13.5% of my data lives right here, and 13.5% of my data lives right here. If we continue this process on, we should be able to talk about all aspects of our normal distribution. So perhaps I want to move on to this section and this section of my normal distribution next. Again, I know that within 3 standard deviations, we have 99.7% of our data. So that's kind of our starting point here. 99.7%, but we need to take away the parts that I've already talked about, which is this 95% right here. I need to subtract that. So 99.7 minus 95 should give me 4.7%. And again, I know that that 4.7% is split evenly between this region and this region over here. So once more, I'm going to take that value divided by 2. I should end up with 2.35%. So that's 2.35% right here and 2.35% right here in almost the tails. Not quite. We're going to talk about those next. And at this point, we've talked about almost the entire normal curve. We certainly talked about kind of the 3 main bullet points for our empirical rule, but there's still a small portion of our normal curve that we haven't talked about, and that's the area in the 2 tails, in the right tail over here and the left tail over here. I know that under my entire curve, I should have 100% of my data because I know that the area under this curve is 1 or 100%. So if I repeat this process one final time and say, well, if I take the total area under my curve 100% minus this 99.7% from my empirical rule, minus 99.7%, I should end up with 0.3%. And then if I, again, take that 0.3% as of right now, that is split evenly between this region right here and this region way over here. So I want to take that and divide it by 2. So 0.3, take that number divided by 2, I have 0.15%. So that means in this tail right here, I have 0.15% of my data and 0.15% of my data. And all of this together kind of accounts for everything we can say about the normal curve with the empirical rule. And what this does for me is it makes problems involving the empirical rule very, very easy. I would have this chart copied down in your notes so that you can reference it as you need to, because it's a really, really handy tool to answer examples like we're going to see in the next video.